You are welcome to this session. So this is session number 6 of Integral Calculus Miscellaneous Exercise. This is presented by E.S. Murugiyan. Dear student, from the last session and fifth session of miscellaneous exercise, and we had completed up to 28th question of the miscellaneous exercise. So in this session, we can begin with and question number 29. So let us start our discussion now. Question number 29. Integral of 0 to 1 dx upon root of 1 plus x minus root of x. Okay. If we look at the denominator, root of 1 plus x and 1 minus x, the difference of 1 plus x and x is constant. The difference. So by rationalization, we can make the denominator constant. Then integral process will be simple one. And how to integrate using a rationalization process. Rationalization. Just on the given integral, multiply, divide by a rationalizing factor of the denominator, that is root of 1 plus x plus root x. So let us start our solution now. So let us take I equal to integral of 0 to 1. We apply rationalization, the numerator will be root of 1 plus x and plus root of x, the denominator, and root of 1 plus x the whole square minus root of x the whole square and dx. We can continue. This is integral 0 to 1 and root of 1 plus x minus root of x, it is plus the denominator a square minus b square, 1 plus x minus x, that is 1, and dx. There are two terms in the integral part, root of 1 plus x and root of x. Let us now integrate. Integral of root of 1 plus x whole power 3 by 2 into 2 by 3, and the other one and 2 by 3 x power 3 by 2. Overall, lower limit is 0, upper limit is 1. And this implies I will be 2 by 3. Taking upper limit 1 plus 1, 2 power 3 by 2, that is 2 root of 2. The denominator, not denominator, we have to subtract lower limit value. Lower limit x equal to 0 means minus 1. And plus 2 by 3, this is for second term. Or 1 power 3 by 2, that is 1 minus 0. So 2 into 2, 4 root of 2 by 3 minus 2 by 3 and plus 2 by 2 is 1. Therefore 4 root of 2 and plus 1 by and 3. This is the required answer and copy it. We'll go to next question, question number 30. Just go through and copy it. Next question, 30th question. Integral with the lower limit 0, upper limit pi by 4. Sin x plus cos x in the numerator. The denominator 9 plus 16 sin 2x. So yeah, dear student, we have discussed already similar question. Now what to do? The sin x should be written in term of sin x minus cos x. So sin x minus cos x, the whole square is 1 minus sin 2x. And this implies sin 2x can be written 1 minus of sin x minus cos x the whole square. Solution. I can be taken 0 to pi by 4, the numerator sin x plus cos x, the denominator 9 plus 16 instead of sin 2x, and 1 minus of sin x minus cos x the whole square. Okay, and dx. Then 0 to pi by 4, the numerator sin x cos x. So derivative of sin x cos x, derivative of minus cos x sin x, the numerator can be written a differential of sin x minus cos x. The denominator 9 plus 16, 25, then minus 16 sin x minus and cos x the whole square. So dear student, if we take t equal to sin x minus cos x, then dt, the numerator dt, we have to change the limit. X equal to 0 implies and t equal to sin 0 minus cos 0, that is minus 1. Sin 0 is 0, cos 0 is 1, minus 1. When x equal to pi by 4 and t equal to 0, sin pi by 4 1 by root of 2, cos pi by 4 1 by root of 2, both are equal, so the difference 0. Now I will be equal to, with the lower limit minus 1, 0, cos 0 is 1, so minus 1, upper limit is 0, and dt by, if we take 25 outside, 1 by 25, not 25, we have to take 16 outside, we have to take 16 outside, 1 over 16, this is 5 by 4 the whole square, minus and t square. Dear student, this implies I 1 by 16, there is no square root term, so log mod of 1 by 2a, 1 by 2 times the constant is 5 by 4, log mod of and 5 by 4 plus t and 5 by 4 minus t. at the lower limit -1, upper limit 0. On further simplification, I use this space. I will be equal to 1 by 16 and 2 into 5 by 4. Actually, this 5 by 2, that is 2 by 5. 2 and 16, 8. 8 into 5, 40. 1 by 40. And log of that is upper limit t equal to 0, 5 by 4, 5 by 4 log 1 upper limit minus lower limit log t equal to -1, and 5 minus 4 is 1, and denominator 5 plus 4 is 9. So 1 by 9. Log 1 is 0. Then I is minus log of 1 by 9 is nothing but plus log of 9 by 1. So 1 by 40 and log 9. The log 9 also can be written and 2 log 3. So 2 by 40, 1 by 20 log 3. So this is the final answer, and copy it. We'll go to next question, and question number 31. Integral with the lower limit 0, upper limit pi by 2, sine 2x and tan inverse of sin x. Okay, dx. Then what to do? The sine 2x can be written 2 sin x cos x. I equal to solution 0 to pi by 2 and sine 2x. If we apply the property, the complementary property, the sin x will be cos x, tan inverse of sin x plus tan inverse of and cos x. There is no change in sin 2x. Sin 2x is going to be sin 2x. Applying the property, f of x equal to f of a minus x. Okay. Then using the property, when we add two result, sin inverse of sin 2x into tan inverse of sin x plus tan inverse of cos x will come. Then again the complication increases. For that, and straight away we can expand the sin 2x is 2 sin x cos x. Then tan inverse of sin x. If we take t equal to sin x, then this implies a dt will be equal to cos x and dx. Then we have to change the limit. When x equal to 0, t is sine 0, 0. When x equal to pi by 2, t is sine pi by 2, 1. So the integral would be written with the new limits. Lower limit 0, no change. Upper limit 1. You can take 2 outside. Sin x t and cos x dx dt. So t tan inverse of t dt. Now we can apply integral by parts. Apply integral by parts. In order to apply integral by parts, the tan inverse of x first function and t is second function, then 2 times 0 to 1 tan inverse of t and d of t square by 2. Actually, what is the derivative of t square by 2? T dt. This is of the form u at dv. Here u equal to tan inverse of t and v equal to t square by 2. Go through it, we will continue. We are going to apply the integral by parts and uv minus integral v du. This is integral of u dv, uv minus v du. Here u is tan inverse of t and v is t square by 2. We continue. I equal to and 2 times u into v. U is tan inverse of x and v is t square by 2 into and tan inverse of t. And lower limit, upper limit minus lower limit is 0, upper limit 1, integral of v t square by 2 and derivative of tan inverse dt by 1 plus t square. Okay. The lower limit 0, upper limit 1. Then and 2 by 2 cancel, applying upper limit and t square 1 tan inverse of 1 pi by 4 minus 0. Then minus and 2 into t square by 2 cancel, minus 1 by 2 integral of 0 to 1. The numerator degree of t is 2, denominator degree of t is 2, equal degree. So adjustment required, then t square plus 1 minus 1 by t square plus 1 dt. Okay. So in the first term is pi by 4 minus 1 by 2 t square plus 1 by t square plus 1 integral of dt alone 0 to 1, then minus or minus plus integral of dt by 1 plus t square with the lower limit, upper limit. And pi by 4 integral of 1 by 2 dt, 1 by 2 t and 1 minus 0, so 1 by 2 alone, and plus this is the tan inverse of t, tan inverse of 1 minus tan inverse of 0, tan inverse of 1 is pi by 4. Then pi by 4 plus pi by 4, pi by 2 minus 1 by 2. So this is the final answer. And go through it. I will show the previous page. Actually this is a question, 0 to pi by 2 sin 2x and tan inverse of sin x dx. I took sin x as t at dt would be cos x dx. To get cos x dx, we have to expand sin 2x using trigonometry identity. Sin 2x is 2 sin x cos x. Then after substitution or conversion of the given integral in terms of t at dt, 0 to 1 t tan inverse of t dt, and 0 is corresponding lower limit of t and 1 is corresponding upper limit of t when x equal to pi by 2. When x equal to pi by 2. Then x equal to pi by 2 means sine pi by 2 is t equal to 1. Okay. So we have completed question number 31. Now we can continue question number 32. 32 integral 0 to pi x tan x, the numerator, denominator secant x plus tan x, secant x plus tan x dx, and we are going to use the property 0 to a f of x dx is 0 to a f of a minus x dx. This is familiar identity, that is properties of definite integral, or this property is also known as complementary property. Okay, solution. Let us take the given one I equal to 0 to pi x tan x, the denominator secant x and plus tan x. Let the result be 1. Applying the property, I is going to be I 0 to pi, x is now pi minus x, and tan x is now tan of pi minus x. The denominator secant of pi minus x plus tan of pi minus x dx. So tan of pi minus x minus tan x, secant of pi minus x minus secant x, and tan of pi minus x minus, so the negative factor recovered everywhere. Then I is 0 to pi and pi minus x, the rest of the term no change, tan x divided by secant x plus tan x dx. Let the result be 2. Okay, now we'll continue. Adding 1 and 2, 1 plus 2 and 2i will be equal to minus x tan x plus x tan x cancel, 0 to pi and pi tan x remaining, then secant x plus tan x. Okay. So pi can be easily, that is x is eliminated now. Now 2i and one more thing, pi can be taken outside, and tan of pi minus x minus tan x, secant of pi minus x minus secant x, tan of pi minus x minus tan x. So there is no change for lower limit and upper limit. Then secant x, if we multiply divide by secant x minus tan x. We multiply divide by secant x minus tan x. The 2I will be equal to 0 to pi. Then take pi outside, tan x into secant x minus tan x. The denominator secant x plus tan x into secant x minus tan x, secant square x minus tan x. So the denominator is secant square x minus tan square x 1 identity. This is 1 by cos square x, sin square by cos square x. So 1 minus sin square cos square by cos square, the denominator 1 dx. Now 2I is pi time integral of tan x secant x or secant x tan x, then minus tan square x, the tan square x secant square x minus 1. The minus or minus 1 plus 1. Okay. Tan x secant x. This tan x secant x tan x is a derivative of secant x. So integral of secant x tan x secant x. Integral of secant square x tan x, because derivative of tan x is secant square x. Then integral of 1 x and lower limit the lower limit is 0, upper limit pi. Now we can integrate 2I will be equal to pi into integral of secant x tan x secant x, integral of secant square x tan x, because derivative of tan x secant square x, then 1 dx ex, lower limit 0, upper limit pi. Then this implies I'll use this space 2I will be equal to pi into upper limit secant pi is minus 1 and secant 0 plus 1. So minus 1 is upper limit minus lower limit. And tan pi is 0 and tan 0 also 0. This is 0. Then pi minus 0 plus pi. Then 2I is minus 1 plus 2 cancel, minus pi, and pi into pi, pi square. Then I is pi square minus pi by 2. So this is the answer, and copy it. Now we have to discuss next question, question number 33. 33 and integral 1 to 4 and mod of x minus 1 plus mod of x minus 2 and plus mod of x minus 3 and dx. Using properties of a definite integral in terms of absolute value function with a different origin, every modulus function can be separated with respect to the origin. How to split up the first one? The origin of the first term 1. So straight away one of the lower limit is 1. Then 1 to 4, if x takes the value 1 to 4 more than 1, x minus 1 is positive. So 1 to 4 mod of x minus 1 normal x minus 1 dx. Then origin of the second term 2 lies between 1 to 4 mean, and we have to separate the limit 1 to 4 as 1 to 2 and 2 to 4. 1 to 2, the origin is upper limit mean x minus 2 is negative, so minus of x minus 2 is positive. Then 2 to 1 and 1 to 2, 2 to 4, the origin is lower limit means is positive x minus 2 dx, plus 3 is the origin, so we can split 1 to 3 minus of x minus 3 dx, plus 3 to 4 plus x minus 3 dx. That's all. We have to split all the three modulus function based on the given origin. The integral of x minus 1 x square by 2 minus x, a lower limit, upper limit, then minus x square by 2 plus 2x, okay, a lower limit 1, upper limit 2, plus x square by 2 minus 2x, a lower limit 2, upper limit 4, then plus minus x square by 2 and plus 3x, 1 to 3, then x square by 2 minus 3x, lower limit 3, upper limit 4. Now we have to simplify, and 4 square 16 minus 1 15 by 2, 4 minus 1 3 minus 3, minus 1 by 2 of 4 minus 1, that is 3 by 2, minus 1 by 2, 2 square minus 1 square, 4 minus 1 3, so this is minus 3 by 2 and plus 2x 2, then 4 square 16 minus 4 12, 12 by 2 6, minus 2, 4 minus 2 2, 2 into 2 4, then minus 1 by 2, 9 minus 1 8, so minus 8 by 2 minus 4, and 3 minus 1 2, 3 into 2 plus 6, then x square means 16 minus 9 7, 16 minus 9 7, 7 by 2 plus 7 by 2, and 4 minus 3 is 1 into 3 minus 3. This should be, last term should be minus 3, and 15 by 2 plus 7 by 2 22, okay, 22 by 2 11, okay, the 16 minus 4 12, 12 by 2 6, okay, then 15 by 2 and 7 by 2 and 3 by 2, 15 minus 3 12, and 12 plus 7, 12 plus 7, 19, 19 by 2. What is this? 19 by 2. Then minus 3 and plus 2 minus 1. Minus 1 plus 6 plus 5. Plus 5 minus 4. 1. 1 minus 4 minus 3. Minus 3 plus 6 plus 3. Plus 3 and minus 3 cancel. So 19 by 2 alone, final answer of, and mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3 and 1 to 4. So let us check this area once again. 1 to 4 x minus 1, 1 to 2 mean negative, so minus of x minus 2, 2 to 4 is positive x minus 2, 1 to 3 is negative, minus of x minus 3 and plus x by x minus 3. Integral of x square by 2, integral of 1x 1 to 4, integral of x square by 2 into minus x square by 2 minus 2x into minus plus 1 to 2, then x square by 2 minus 2x, 2 to 4 minus 2x. Then next minus x square by 2 minus or minus plus 3x and x square by 2. This x mean x square by 2 minus 3, integral of minus 3 minus 3x. Now we have to apply limits. Then 4 minus 4 square 16 minus 1 15 by 2 and 4 minus 1 3 and 2 square minus 1 4 minus 1 3 minus 3 by 2 and 2 minus 1, so 1 into 2 2. Then 4 square 16 minus 9, 16 minus 9, 1 to 2. The first two term is separate term. This is 15 by 2 minus 3, then this is minus 3 by 2 and plus 2. Okay, then 4 square minus 2 square 16 minus and 4 12, 12 by 2 6, correct. Then 4 minus 2 2 into 2 4, this is also correct. Then 3 square minus 1 9 minus 1 8 by 2 minus 4, correct. 3 minus 1 2 3 into 2 6, correct. And 4 square 16 minus 9 7 by 2, correct. And 4 minus 3 1, so minus 3, correct. So this is the answer. So dear student, so let us wind up and today's session with the 33rd question of the miscellaneous exercise, and still we have to discuss from the same exercise from question number and 34 to and 40. In between the limits of sum is not required, then we have to discuss. So 34 to 40 we'll discuss in the next class. So let us wind up today's session, and thank you students.